Good afternoon and welcome to the October MarkLogic community event. Happy Halloween if you're celebrating that from our colleagues across the world. But thank you very much for joining us today. Joining me will be Rob Rudin, Senior Principal Software Engineer for Progress, and he's going to be talking to us today about some of the latest developments that are coming into the platform, especially with our new product called. That would be great. Let me just make you the presenter here. There we go. Pass over the controls to you. I'll stop sharing my screen. And there you go. I can see your screen, Rob. That's okay, great. Thank you.
Thanks so much, Phil. All right. Yeah. Good morning. Good afternoon to everybody. I am going to be going over our new Flux application. Today, I'm going to be giving a demonstration of it and also showing some of the new features on our roadmap that we're working towards a release for. So let's first go through an introduction to Flux here. So if for any sort of application that you're building today, it's very likely that you're going to need to pull data from many different places. That data is going to be in different shapes. It's going to adhere to different schemas, and bringing all of that data into one place can be a real challenge. And when I first started using MarkLogic 16 years ago, a light bulb went off in my head when I realized I can bring all that data into one place, into one data platform called MarkLogic. It doesn't matter if it's JSON, XML, text, or binary. It doesn't matter what schema it is. It doesn't matter if it doesn't have a schema. I can bring it all into one place. I can index it, and I can start to build very powerful applications on top of MarkLogic. And we've often said that data is easy to get into MarkLogic and easy to get out. And there's a lot of truth to that. But we know, for me as formerly a customer and as someone who's built a lot of applications with MarkLogic, we know that while it's easy to get that data in because we don't have to worry about schemas, we don't have to model the data up front, actually accessing the data and getting it into MarkLogic hasn't always been that easy. Now, for many years, we've offered an excellent tool called MarkLogic Content Pump that is very good when your when your data is on a file system. And then you normally have a simple command line experience for getting vast amounts of data into MarkLogic from a file system. But obviously, data can live in many different places. And one of the main problems we wanted to solve with this new Flux data movement application was greatly expanding the number of data sources that we can support for getting data into MarkLogic, and also for being able to take data out of MarkLogic and send it to a variety of destinations as well. And that's what I'm going to walk through in the demonstration today, is really making this diagram much easier to accomplish than previously, just because of the expanded number of data sources and features we provide in Flux. And we're going to look at importing data, exporting data today. You can also reprocess data that's already in MarkLogic, and you can copy it from one database to another, or from within one database to a different location in that database as well. And we'll touch on those in the demonstration. A few high-level things to call out about Flux. It's very similar if you've been using MLCP, MarkLogic Content Pump, or Chord, our main reprocessing tool. Both of those provide a command line interface. That's going to be the predominant way that you'll interact with Flux as well. We provide a number of commands based on the different data sources and try to make it as easy to use for getting, again, vast amounts of data into MarkLogic with a simple set of options so that you can very quickly get that data in or get it out. The item in the upper right there, ample data source support, as I've touched on, that's really one of the key features here. And we'll definitely dive into that in the demonstration. And then one other thing I wanted to call out below was it's both standalone and embeddable. One of the things we wanted to design for was being able to embed Flux within your own JVM-based application. It's often useful to build three-tier applications where a user may upload a file, or maybe they want to download data from MarkLogic. You can use Flux as a library, so you're not going to use the command line interface. You just depend on it as a normal Java dependency, and you can start taking advantage of all of the features in Flux within your JVM-based application. And then finally, before we get into the demo, I've talked a lot about data sources. One of the things that's real exciting to me here is within Progress, we offer dozens of different JDBC drivers via Data Direct. I'm going to switch over to a list of those drivers. So if you go to progress.com/JDBC, you can see it in my browser there. There are dozens of different drivers listed here. And because Flux supports both importing data from via JDBC and exporting data from MarkLogic via JDBC, all of these data sources that you see here are now easily accessible via Flux. Prior to that, we often were having to build bespoke applications. We might be using the MarkLogic Data Movement SDK. We might be writing a pretty good chunk of custom code to interact with these data sources, but no longer. We can use all of these different JDBC drivers based on what data source we need to access. And then just to tie it all together, MarkLogic, excellent data platform, but we really can't do much with it unless we can easily ingest data from a variety of data sources, and that's what Flux now empowers. We offer a variety of support for then further enriching that data within MarkLogic. And then finally, what are all the different ways that we want to access that data and visualize it and disseminate it to other systems? Flux is going to be a big part of exporting that data as well. All right, and so I am going to go into our demonstration next. And I first want to just call out where you can find Flux. This is an open source project that lives on GitHub. If you go to the releases page, sorry, I should have clicked on this first. There we go. You can see all of the releases of Flux so far. We're currently working on our 1.2.0 release, which I'll be showing a preview of as well. The documentation is accessible from our GitHub repository as well. And I'll just click on a few things in our documentation just to give you a sense of all the different data sources that we support. So when we look at importing data, you can see a list of all the different files that we support, different types of files, different locations that we can read from. Obviously, importing from JDBC is a very critical feature. And same goes for exporting data, a number of different ways that we can get data out of MarkLogic. I should point out both of those are extensible. We have an approach where you can write custom code if needed to integrate your own data source in case Flux does not support it yet. There is a path towards, for example, writing it to any data source you can think of and reusing all the export capabilities we have already in Flux. All right, so let's start with the demonstration here. I am going to be using a simple database. I'm running MarkLogic locally on Docker here, and I've got a simple 3-forest database that is currently empty. I'm going to switch over to Visual Studio Code here, where I have all the commands that I'm going to be executing as part of this demo. And so we're going to start off with something simple. This is something that you're able to do with Content Pump today. And we've replicated all of the Content Pump functionality, so it's in Flux, in addition to all the other data sources that we support. But let's just do a simple import first, and we'll talk about what are some of the basics of using Flux. So we have a number of different commands. There's one for every different data source that we support. In this case, we're providing a couple required options, namely what's the path of the data. So we have a delimited file, a CSV file that's been gzipped here, has 1,000 rows in it. We can specify a connection string. We support every connection strategy that MarkLogic supports as well. So one-way SSL, two-way SSL, Kerberos, connecting to Progress Data Cloud, those are all supported with Flux. And then we're a non-admin user here, so we're going to just specify a couple of permissions, a collection for all of the documents that we're going to create, one document for each row in our CSV. And then one of the nice features that we have is for most of our import commands, we can specify a URI template. So we can construct URIs based on the data that's in each document. And so what we're doing here is we're constructing a URI that includes the value of the ID and the last name columns in each row in our CSV file. Okay, and so I am going to be running each of these in a simple terminal here on my computer. So I'm going to copy this, paste it in here, and then run it. We'll see a few lines of logging. Flux is Flux's logging is configured via log4j. That's all configurable as well. So if you ever need to turn on, for example, full debug logging, that's a simple thing to do. All right, and we're going to go back to Query Console and take a look at the data that we just imported. And so sure enough, we're going to see 1,000 documents, one for each row in the CSV, and each URI is based on the data in each document. So you can see the IT and the ID and the last name. Take a look at another document here again, just as we had expected from that CSV. So very simple, just like we've been able to do with Content Pump. So let's move on to something a little bit more interesting, which is importing data via JDBC. And hopefully if you've used tools, there's dozens and dozens of tools out there that support providing a JDBC driver to the tool and then specifying a JDBC URL and the name of that JDBC driver. And that's typically all you need to do to integrate that tool with whatever your JDBC-based data source is. That's the exact same user experience that you're going to have with Flux here. In my case, I'm running a small Postgres data locally. I've got a Postgres tutorial data set loaded into it. We're going to be looking at the schema for that in just a moment. And so I'm just connecting to that local Postgres database. Obviously, this JDBC URL will change depending on what type of database you're trying to access. And then I provide the name of the JDBC driver and then a few other simple inputs. In this case, we're just going to select every row from the customer table in this Postgres database. And then very similar to the import that we just did, we provide some common inputs of how do we connect to MarkLogic and some metadata for every document. All right, I'm going to paste this in, but before I do that, you might be wondering, well, how does Flux have access to the Postgres JDBC driver? So the solution for that is Flux has an ext folder. When you download and unzip Flux, there's an ext folder, and any jar that you place in that directory will be added to the class path of Flux. So that provides a very simple mechanism where you can obtain the JDBC driver for your data source, put it into the ext folder, and you're now ready to access that data source with JDBC. Okay, so I'm going to paste that command into my terminal here, run it, and we'll give that just a few seconds to complete. And so as always an odd number, I use this data set for a lot of demonstrations. There are in fact precisely 599 customers in the Postgres data set. Not sure why they didn't make that an even 600, but 599 is in fact the correct number. Let's go to Query Console and take a look at that data. All right, and sure enough, our URIs are constructed the way that we expect based on the URI template that we provided. And we have a JSON document with one field for each column in the Postgres data set. And I just want to show that schema briefly. We're going to revisit this in just a moment when we talk about aggregating data together, but you can see that customer table there with, sure enough, each of the columns is now in a JSON document for each row in our database. All right, now that we have data in MarkLogic, a common use case that we've used an application called Chord for many years for is to reprocess that data. We might want to change the contents of documents. We may want to change the permissions on the data. In this case, we're just going to do something very simple. We're going to add a collection to each of the documents in the employee collection. Those were created when we imported that CSV file. And reprocessing, much like the Chord tool, reprocessing gives you a chance to write any custom code you want to run in the MarkLogic platform. To read data, often you're going to read URIs out of MarkLogic, but you're not limited to that. And then you can write custom code to manipulate the items that you read. So in this case, we just do a simple query to get all the URIs in the employee collection. And then we do a simple JavaScript statement to add each URI to the reprocess collection. And so let me go and clear that just to make it a little bit more readable. I'll paste that in my terminal and run it. And once that completes, we'll go over to Query Console and see, sure enough, we scroll down here to the employees, you'll see that every employee document is now also in the reprocess collection. So right away, we've shown how if you've been using Content Pump and Chord, you've been using those for different use cases, right? Content Pump, you can import, copy, and export data. Chord, you can reprocess that data. We've now got one application where you can support all of those use cases with a far greater set of data sources as well. All right, and now let's show how we can do an export. And one of the features we've long wanted to support is making it easy to get data from S3 into MarkLogic and vice versa. And so what we're going to do here is a simple export. We're going to export every document in the employee collection as a file, but we're going to zip all of them up into one zip file. And we're going to write this to one bucket that I have in S3. This is protected. I call it my public bucket. It's only accessible to me though. And then to make life easy here, Flux integrates under the hood with a AWS SDK, which knows how to find your credentials. It'll look in several different places to find those. All we need to do as a user is just add an option to tell Flux, add my S3 credentials. And under the hood, Flux will use the AWS SDK to find those credentials. And so do a clear again. I'll paste this into my terminal. And that will collect all 1,000 documents from the employee collection and then write them to one zip file to that bucket in S3. So this has been a long sought feature for MarkLogic users, is providing that easy button, that easy integration with S3, and we now have it. And it's for any type of file as well. So whether it's delimited files or Parquet files or Avro files, there's a whole variety of files that can live on S3. We can easily import them into MarkLogic, and we can easily export data from MarkLogic to any of those file types with S3 as the destination. All right, let's go back to the demo script here. Now, oftentimes when we're exporting data, we want to get a sense of, well, what's that data actually going to look like? We might be exporting 100 million documents or more. So one of the features we wanted to provide in Flux is for any command, you can do a preview where the command won't actually import data or it won't export data. It'll just show you what the data looks like when it's been read from whatever the command's data source is. So in this case, I'm running a command where I want to export data to Parquet files. Now, Parquet is a tabular data source. Flux supports a number of tabular data sources. And anytime we want to get data out of MarkLogic into a table, whether that's via JDBC or Parquet or another data source, we're going to use a MarkLogic optic query. So that allows us to project data in documents into rows. And so I've got a very simple optic query set up. I have already set up a view beforehand with a schema name of example and a view name of employees. This is going to project each of those 1,000 documents in my employee collection into a row. But really what I want to do first is see what that data is going to look like before I export it. So I include the preview option and I tell Flux how many rows do I want to see. Okay. And I'll do another clear here to make space. I'll paste that into my terminal. And Flux will then display the first 10 rows that it gets back from that optic query. And so for a tabular data source, this is exactly what I want to see. What are all the column names going to be? And then what does the data actually look like? And now I know if I'm writing to a relational database or writing to Parquet or writing to a CSV file, I know exactly what my data is going to look like before I take on what could potentially be a massive export that takes a while to complete. Now, another thing I can do is I might not know how much data I'm actually going to export. So instead of using the preview option, I'm just going to add count here. And this will be very much like a preview. It's just going to read the data and then give me a count of how much data is actually in the data source. And so we can see, instead of getting a list of how many documents were exported, I just get a count of 1,000. So that can be very handy, particularly when you're interacting with data sources like a Parquet file where you may not know how much data is actually in that file, and you want to have some idea of what kind of scale are you talking about before you start what could be a long-running import job. All right, and now let's go back to importing data via JDBC. One of the challenges we often run into when we're taking data from a tabular data source, like a relational database, is there's often not a lot of value in just taking every row in a table and making it into a document in MarkLogic or in any document data source. And so if we look at that schema for the Postgres data set, we can see there's a lot of relationships between the tables here. And what we're going to do is key in on the relationship between the customer table and the payment table. So it's a classic one-to-many relationship. Every customer has many payments. And if we just put every customer into a document in MarkLogic and every payment as a separate document in MarkLogic, we're not really taking advantage of what a document database, and particularly MarkLogic, can do in terms of indexing and querying the data, in terms of applying permissions to the data. You know, if we think about how do we really view this as an entity, we might say, well, you know what? We think customers own their payments. We really like for payments to be part of that customer entity. We really want to aggregate that data together into one document. We could do that for a number of relationships in this diagram. Now, we might have a use case to keep the payments separate, and that's fine. That's easy to support. But really, with Flux, we want to make it much easier to basically take those tables where the data was ripped apart and recombine it, re-aggregate it together into these logical entities that make much more sense from a domain model perspective. Okay, so the way that's going to work in Flux is we're first going to write a SQL query that does a join between the customer and the payment tables. So fairly simple join query in SQL here. I'm selecting all the customer columns, and then I'm grabbing a few columns from the payment table, and then I just do a simple inner join on them. But then I use two additional options to tell Flux how I want to aggregate the payment data into the customer documents. I first tell Flux, I want you to group all of those rows by customer ID. And then I can use the aggregate option one or many times to express different aggregations. And the syntax for this is I define first the name of a new JSON array to add to my customer document. That name is going to be payments. And then I say which columns do I want to be added to, and which columns should be used to create an object per row in that array. So the end result here should be that every customer now has a payments array with one or many objects, one for each customer payment row, and each object should have these three fields on it. So let's run that and take a look at what the data looks like. Do a clear, paste that in, and let it run. You can see my URI template starts with aggregated. I'm going to use that just so we can easily find those new documents. Scroll down, let's use the search bar here, make it easy. So here we go. Let's open up this first one, and we can see we've got all the columns from the customer table just like before, but we now have that payments array as well. We can express as many aggregations as we want to create much more rich entities as opposed to just having these be a lot of flat JSON documents in different collections, which could make queries and updates much more difficult. Now, right now in Flux, we're only supporting one level of nesting, but that's one of the main features on our roadmap, is being able to support as many levels of nesting as you want. So you can form these very rich hierarchical entities. And this isn't just limited to JDBC. Any data source that is tabular in nature, so again, Parquet files, CSV files, we can apply that same group by and aggregation logic to form rich hierarchical entities in MarkLogic. All right, and for the last two items in our demonstration here, I want to give a preview of the main features that we're working on for the Flux 1.2 release. So in our previous community event, my colleague James Kerr talked about some of the new exciting features in MarkLogic 12 for supporting RAG, Retrieval Augmented Generation use cases with AI. Now, one of the challenges with RAG, particularly when you can ingest large amounts of text or large amounts of any data into one document in MarkLogic is you may find a document that's a really good match for a user's query, but the amount of text in that document is too large to send to your LLM. And so you have this use case for splitting your text up. And for our 1.2 release of Flux, we're going to be embedding, I shouldn't use the word embedding, that's a little overloaded. We're going to be reusing a popular open source project called LangChain for Java to provide access to many different LLMs and to support many use cases related to RAG, such as splitting text. And I want to just briefly show some of the information on the LangChain for Java website about splitting text. You can find a lot of information about this on the internet. This is a pretty good summary of some of the reasons for why you would want to need to split your text. So again, the amount of text in one document MarkLogic might not fit in what you can send to the LLM. It may take longer the more text you send it. You may pay more as well. You might also, for example, maybe you match on a couple sentences in one document in MarkLogic, but there's hundreds of other sentences. Well, now you're providing all this other information to the LLM that's not really related to the question, and that might reduce the reliability of the results that you get back. And so splitting provides a way for us to break up all that text into smaller chunks, which we can then return to the LLM. And now we've done a lot of work with RAG internally at MarkLogic, and we know that splitting can involve a fair amount of custom code. And so what we wanted to do was start providing an easy button, making use of LangChain for Java, so that you can start splitting the data in your documents during import and during a copy. So for example, you might import your documents first and realize the text chunks in them, they're too big. You need to split them up. You can use the copy operation in Flux to split them. For this demonstration, I'm going to show how we import one document and split the text into smaller chunks. And first, I just want to show what that document looks like. I just made a simple one. It's not a particularly large amount of text. It's around 2,000 characters or so, but it's enough where if I were to do a search and hit on maybe 10 documents of this size, that might be too much to send to my LLM. And so I've just taken some text from our Java client documentation, and we're going to import this document and we're going to split that text up into smaller chunks. And the way that we do that is we provide one of two arguments. We either need to provide a JSON pointer, and we can provide multiple JSON pointers to tell Flux where is the text that we want to split up, or we can provide an XPath expression if we have XML documents. We then have some optional arguments that I'm making use of. We're going to tell Flux our max chunk size should be 500 characters. We don't want any chunk to be larger than that. And we don't want to actually modify the incoming document. We want to create what we've long called sidecar documents, smaller documents that have a pointer to the source document, and those will have all the chunks in them. Now, depending on your use case, you may want all the chunks in the source document. Neither approach is right or wrong. We want to make sure that whatever solution works for you is easily accomplished with Flux. And so I will paste this into my terminal and run it. And then we'll take a look at the results. And just to make it a little easier to see the data in QConsole, I'm actually going to delete all the data that I loaded already, just so I can hit Explore, and my 3 documents are right there. So first, let's just look at the original document, and that's been ingested as is, no modifications made to it. We then have 2 chunk documents. The reason being is that Flux used a default splitter in LangChain for Java, and that created 4 chunks based on our max chunk size of 500. And since we said we want at most 2 chunks per sidecar document, we ended up with 2 documents with 2 chunks each. And now we've solved that initial problem of when we do a search on this data using MarkLogic's powerful indexes and query language, we can match on much smaller blocks of text, which should address a number of those problems that we saw in the LangChain for J documentation. Okay, so that gives you a preview of how splitting works, there's a lot of other features, including the ability to write your own splitting logic. There's really many different ways to split text up, and we want to make sure you're not limited by the options that Flux provides out of the box. All right, now let's talk about the final piece here of a RAG solution. And I do want to go back to the slides for just a moment. Should have mentioned this first. So when we're doing RAG with MarkLogic, it's these first two steps that I want to talk about here. We just talked about splitting documents into chunks and why we would want to do that. The next thing that we want to do is, in order to take advantage of all of those great capabilities that James Kerr showed in our previous community event, we need to add vector embeddings to the documents in MarkLogic. And again, based on our own experiences internally, we know that this can require a fair amount of custom code. If you're trying to do this from scratch, you might use our data movement SDK. You may grab something like LangChain for Java or Spring AI or some other LLM framework. And you're probably going to write a non-trivial amount of custom code and probably do a lot of testing and debugging as well to get your solution working. We want to make it a lot easier to be able to add embeddings to your data. And so that's what I'll show in the final demonstration here. So we're going to do the same thing that we just did. We're actually going to overwrite that data that we just wrote. So we provide the same inputs for splitting the data, but this time we provided some options for using the embedder feature in Flux. And one of the challenges, without getting into too many technical details here, is when we integrate with something like JDBC, we know that the JDBC convention is there's one file you can get for your database, and that's all you'll need. We're not quite there with being able to interact with different LLMs. And so one of the things we're going to do with Flux is provide a number of out-of-the-box implementations using LangChain for Java for some of the popular LLMs out there, such as Azure OpenAI. And that's the embedder that I'm going to use in this demonstration. So I tell Flux I want to use the Azure embedder, and then I use this -E option for providing options specific to that embedder. Each embedder is going to have a different set of options. And for the Azure one, I need to provide an API key, which I've defined as an environment variable. And then I need to provide an endpoint, and finally a deployment name. And again, depending on the LLM that you'll use, you may have a similar but different set of options. Those will all be specified via -E, which lets you define any key name, an equal sign, and then any value. Okay, so I'll paste that into my terminal for the last demo here, and then we'll look at the data in QConsole and see the embeddings that were added via the Azure OpenAI service. So go back to Query Console, do an explore. Again, our original source document is unmodified. And then we look at the chunks, and sure enough, each chunk object in the chunks array now has an embedding. We can now index this using MarkLogic 12, and then use the MarkLogic Optic query language to perform similarity queries based on a user's chat question and comparing it to the embeddings that we've added to the chunks in our documents. So in our experience, this has greatly simplified the process of getting a RAG process up and going with MarkLogic. There's a lot of tweaking we may want to do still. We may do that on the Flux side, on the MarkLogic side, on the LLM side, but we've greatly sped up the process of getting that data split up and adding the vector embeddings, and we can now start integrating with LLMs and building powerful RAG-based applications. All right, so I touched on some of the things that are coming next. You can see kind of a high-level roadmap here. Our Flux 1.1 release, one of the main features was being able to stream documents. So if you have documents that are massive in size, like a 20 gigabyte binary file, you can now easily import and export those. For Flux 1.2, we're supporting document splitting. We do have Flux 1.3 on there for vector embeddings. That may very likely slide into Flux 1.2 as well. Again, these are tentative plans, but that's the general idea of where we're going with Flux. And of course, we're always eager to hear feedback from customers and what are other data movement use cases that we can provide easy buttons for, so you can more quickly get data in and out of MarkLogic and build those powerful applications on top. All right, Philip, that is all that I have. I'm going to stop sharing and turn it back over to you.
Great. Rob, thank you very much. Really, really interesting. There's a lot in there. I still think there's a lot more to come from that tool. It's really interesting to see the features that you're looking to put into the product in the future. One of the questions that I had as I was watching it is, obviously we've got the demos there and things like that, but you were part of the team that helped develop this thing. And I was thinking, like, what was your wow moment then? What was the thing that went, do you know what, actually, we should be doing this for customers in a fully supported manner?
And Phil, do you mean that specific to RAG use cases or just generic to Flux itself?
I think they start off with Flux if you've got one for Flux, and if you've got one for RAG, great.
Yeah, well, so I started my experience with MarkLogic as a customer. Back in 2008, I wondered, what in the world are we doing with this XML database? Everything I knew was just relational databases. And once I started getting data in and realizing all the different things we could do with indexing the data, we didn't have to build schemas. Again, the light bulb went off. I was like, wow, we can do some really powerful, amazing things that would have taken us far longer to do with a relational database. But over the years, I just felt like we never really got to where we needed to in providing those easy buttons for accessing a variety of data sources. Now, some of you may know Flux is actually built on top of our MarkLogic Spark connector and the Apache Spark platform. And so I'd say the wow moment, which was not unique to me, this was really a collective effort. I mentioned James Kerr before, he was a huge part of this, was when we realized, you know what, Spark is really that plumbing that we've needed for this sort of an application. Content Pump was built on Hadoop. So Flux is really pretty similar to MLCP. Spark is built on Hadoop, but Spark provides that ecosystem of all of those different data sources. And its notion of reading data into a data set and then writing that elsewhere is just a great fit for what we're doing with Flux. And I think a really great solution for customers' data movement use cases.
Yeah, no, it is really good, and it's great to see that simplicity being offered to new applications like RAG and things like that, and the development that you're doing there. One question is Flux an independent component with an additional cost? No, I don't think it is.
Yes, it's an individual, it's a separate component. No, there is no cost. This is open source, it's fully supported, but underneath the Apache 2.0 license. So everything we do is in the open. You can grab a release. You could actually build off of the developer branch whenever you wanted to as well, just like any true open source project. And again, we really hope that, I've used MLCP and Corb very happily and very successfully for many years, but we really felt like it was time for that next generation tool to address some of the additional use cases. And I hope for folks that have used Content Pump and Corb, but maybe run into some limitations in terms of use cases, give Flux a try. And we think you're gonna be really pleased, and again, always welcome feedback too.
Yeah, no, it is great. And there's loads of ways to give that feedback, by the way. You can reach out to your account manager, your CSMs, you can raise support tickets for feature requests, but you can also raise community forum posts. You can ask questions in there about the technology as well. And a lot of these guys will monitor those and come back to you with answers to the questions. So they're all monitored by our team of engineers, developers, and consultants. So it's worth joining our MarkLogic community forum for that. That website again for where the GitHub instance is just github.com/MarkLogic/Flux. So you can find that on there. That's nice and easy. And again, yeah, no additional cost. It's an open source project, but we're fully supporting that. You talked about, and I think the way you put MarkLogic 12 and you put those different headings in there about it being, more scalable, more secure, more is that a philosophy that you're kind of taking through now with MarkLogic 12, 13 and beyond, making the product more accessible for people, making it more functional, especially with these new use cases coming through?
For sure, yeah, more observable was one of the key bullet points there. That's our attempt to look at what are industry standards for observability. How do we support those with MarkLogic, which I think is a really exciting thing to do. I often feel like we can't emphasize more secure enough. I think the security model in MarkLogic has long been one of the outstanding features that we probably don't talk about enough. And particularly with use cases like RAG, being able to secure your data so that only certain amounts of data are eligible for RAG, and also making sure that that data maybe can't be modified or accessed by regular users of an application. I just feel like our security has always been extremely powerful, and it's, in my mind, only going to become more relevant.
Yeah, I noticed that with when you looked at that chunking and you moved the chunks into separate side documents, as you called them. That's great for not only security but governance and regulatory compliance as well, because you can show the regulator this is how these things were created. No, we haven't touched the original. You can still see the difference there, and I think that's really an important thing, especially when you're looking at the overall conversation around data management, data governance, and data security with RAG and Gen AI and AI in general. So yeah, really good to see that feature there. And finally, you talked briefly about the JDBC drivers from DataDirect, and I think that's really a key point to get across. We are progress. We're progress MarkLogic now, and I think there's a lot of work going on in the background about connecting these technologies further and offering you more of a platform approach. And are you seeing that in the product development side of things?
Sure. Yeah, and I think there have been a number of products within Progress that we've seen the potential for useful integrations, Corticon being another one. But DataDirect certainly stands out. It was really a good, combination of when we decided, hey, Spark provides a really good foundation for our next generation data movement tool, and Spark makes it very easy to do JDBC. And then we look over at DataDirect and there's dozens of JDBC drivers. That was probably another wow moment, where we can give customers this tool and say, listen, check with our friends at DataDirect, look at all the different sources that they support. And I think to your question, that's always something that we're looking at, is when we're considering a different customer problem, what solutions are there already in progress that we can just point our customers to and say, hey, this is going to work great with the MarkLogic platform. And I think that's very exciting, just being able to have that integration and not having to reinvent wheels and reuse what's already part of Progress.
Yeah, and I think that's going to be even more so next year with the acquisition. I know that's been put out in the press around ShareFile, so that's going to be interesting to see what comes next year with that as well. But yeah, I think there's a real sense at the moment where you've got to look at that data stack that you have in your business, that technology that you are using to power AI in your business. So it's a really interesting time for not just us, but for our customers as well. They're coming to us with some really interesting use cases for our technology in that area. So
yeah. Phil, I'd be remiss not to add one of the other very interesting integrations we're looking at is with Semaphore. We know that Semaphore has very powerful capabilities for tagging data based on a taxonomy. And so it's a very natural thing. If I'm going to import data from a data source, I'd like to have the option of running that data through Semaphore and leveraging my taxonomy there and getting all of those tags added as it's being written to MarkLogic. So that's another integration that, again, we want to provide an easy button on. We often joke that our goal with Flux is never to invent anything, right? We just want to provide those easy buttons so that life is easy for customers that are moving data from one place to another.
Yeah, no, I think that's a great approach, and I think as well the what was I going to say? It was for Flux, for MarkLogic, for Semaphore, for Corticon, and all those other pieces. I think there's a real push in the business to make that more accessible, not just to data-related people, but also business-related people as well. And it's going to be interesting to see some of that come down the line as well. One last thing then, what are you most looking forward to? Because we're getting towards the end of the year. I'll take your 2025 prediction now. In October, what are you most looking forward to next year or is it changing so fast you couldn't put your finger on it?
Well, I do think, you know, and I can, you know, I'm not much of a prognosticator. I will say that the industry attention to RAG, I think has put MarkLogic in a very good light because, you know, RAG is all about how do I find the most relevant data. I can't send a lot. I need to find the most relevant chunks of data in my database and send that over to my LLM. Well, we've been talking about relevancy for over 20 years at MarkLogic, and so many of the features that have gone into MarkLogic, whether it's geospatial queries, bitemporal queries, security-based queries, there's so many powerful ways to index and query your data with MarkLogic that it seems like this attention to RAG is just a great fit for MarkLogic. So I'm excited about how do we make it easy for users to get their data ready for RAG and then start leveraging all of these capabilities that we've had for 10 or more years for finding the most relevant data. Semaphore is a part of that. The new vector-based queries in MarkLogic 12 is a part of that. I think that's going to be very exciting and just a chance, you know, to discover all these great capabilities that we've had that are just a great fit for what is a priority in the industry today.
Yeah. Great. Yeah. Cheers. Thanks for that, Rob, and thanks for the presentation today and putting those demos together. They were really good. One last thing, if you want to have conversations with Rob, the PM team, members of our engineering team, you want to provide feedback, you want to get more involved in maximizing the value of your investment in our products by helping shape product discussions and things, then we have something called the CVP program, or customer validation program. And it's a really good way of engaging with the product development team, with the engineering team, and being able to provide feedback on our product. We put new releases in there, we put early access, we put access to pilot programs in there. So if you're interested in that, you can find more information in our community forum. We'll put some links in the on-demand description when we finish today's session, but it'd be well worth signing up to some of those if you already haven't. But I think we've got to the end of that one. So Rob, once again, thanks very much for joining us today, for prepping, for doing all of that work. Thank you very much to everybody who joined us. I believe we've got another session next month, just before the end of our year here. Yeah, once again, thanks very much for joining us, and we look forward to seeing you again soon.
Thanks, Phil. Thanks, everyone.
Cheers. Bye.